Well, there's much to say except that today's presenter is Andressa Cristina Ramaglia de Mota. I'm sorry for butchering your name right now, Andressa, with my poor Danish accent. But before we begin, I'll just use a minute talking about AquaVitae, which is a project supported by the EU, which aims to increase aquaculture production in and around the Atlantic Ocean by developing new species, processes, and products. The focus of the project is placed on low-trophic species such as algae, sea urchins, shellfish, contributing to circular economy and the Bill statement. I will be sending a link about AquaVitae in the chat, and you can go to the webpage and you can find out a lot more about the project. But without further ado, I would like to turn to Andressa. And before we begin, Andressa, I know you're going to present yourself in a little while, but before we begin, could you please talk a little bit about why you became interested in nature and climate change?
So, in my opinion, my interest in nature when I was a child. And even though I live in an urban city, when I was a child, I spent the holidays at my grandmother's house. And who lived in a house close to nature and raising some animals like chickens and pigs, which I helped take care of. Besides, when I stayed there, we went fishing, hiking, and observed nature during the days. And this memory started my interest in climate change. So my interest in climate change came from the knowledge that our lifestyle nowadays can after all the memories of my childhood. And in addition, the effects and change our ecosystems. Once it's already interfered in animals' lives, I think is in this moment.
Thank you very much. So, would you like to present now?
Yes, I share for you.
It looks good.
Can you see? Yes?
Yes.
So I'm started. Good morning or good afternoon, and thank you, Casper. I will start my presentation. It's a pleasure to be present on more work in the Low-Trophic-Life webinar for you. And today, I'm going to talk about the synergic effect of the Atlantic Ocean acidification and salinity variations in the physiology of the white-leg shrimps Litopneus vanami. So, first, I'm talking a little bit about myself. My name is Andressa Ramaglia. I'm graduated in marine biology by UNESP and got my master's degree in aquatic biodiversity, also by UNESP. Recently, I'm doing my PhD in the Aquaculture Center of UNESP, working specifically with the physiology of economically relevant organisms in Brazil. My supervisor is the PhD Professor Patrícia Valente, and our experiments are made in Sustainable Aquaculture Lab at the Aquaculture Center of UNESP in the Coast Bioscience Institute of São Paulo, which is coordinated by the PhD Professor Alessandro Augusto, my co-supervisor. The research lines at lab are climate change, microplastics, carrying capacity and nutrition, and the others. And besides, the studies of diverse economically relevant organisms with many species of crab, the freshwater shrimps Macrobrachium amazonico and Macrobrachium rosenberg, the marine shrimps Litopneus vanami, and the others. So let's start talking about the general filters of aquaculture. The aquaculture is the fastest growing food production sector in the world, accounting for over 50% of global fish productions. So besides, is an important source of income and livelihood and is often promoted as a solution for meeting the growing food demands of this century. So, according to the Global Aquaculture Alliance, 62% of fish for food will come from aquaculture by 2030. And in contrast to the growth of the aquaculture sector, the threats generated by the climate change may have an impact on production systems and therefore on human food. As you can see on the map, when many coastal areas may be affected by climate change. Forecasts in this area point to a general reduction in agriculture productive in tropical and subtropical regions, which are already a sensitive area of populations, concentrations, and convergence. From this perspective, aquaculture gains significant attention, including the recent IPCC 1.5 report, which identifies aquaculture as one of the key sectors that requires attention on global food security and the upgrade of adapting policy. So, in this context, aquaculture and climate change can be connected into two ways. The first is how climate change interferes in the aquaculture productions. So the impacts of climate change raise the complexity and uncertainty of the aquaculture systems, what can result in several adverse conditions such as disease, infrastructure destructions, decreasing growth, and the others. So besides, changing many known information about the cultivated species due to change in the physical-chemical patterns of the water. The second way is the influence of aquaculture on climate change. The aquaculture is particularly responsible for 385 million tons of CO2 released into the atmosphere per year, about 7% of the contribution of the agriculture sector. But, on the other hand, its currently also look for more sustainable production systems, such as a multi-trophical systems IMTA. Aquaculture systems are undergoing rapid change and must be able to adapt quickly and seize opportunities, such as the other research systems widely studied in the climate adaptations. So, the impacts of climate change manifest themselves in several ways. They can be direct or indirect, and some of them can act synergically or secondary. Example, the salinization of deltas after sea level rise. So among these topics present, our project fits into the first way that seeks to understand what will be the impacts of climate change on organisms. So what is aquaculture adapting to? And how is adapting? So what research gaps to be need addressed? That are some of the questions we try answer in this project. However, studies on these effects need to be understood as soon as possible, because nowadays the effects of climate change can already be observed in several areas of fisheries and aquaculture. So they are no longer just predictions or models. They are real economical, social, and environmental impacts. And there we have some examples. So the increase in temperature is causing demands in the fish farming of tilapia, and in the USA cause the ecological disturbance of lobster. The increased temperature so the algae growing, causing death in thousands of salmons in several farms in Chile, and extreme climate events will be even more frequent, what also affects aquaculture production, as for example, the destruction of an oyster farm by Hurricane Michael. And the ocean acidification is forcing oyster companies to change regions due to water acidity. So the ocean acidification has been gained prominence among the climate change. So since the beginning of industrial age, near half anthropogenic CO2 is accumulated in the atmosphere and contributes to the greenhouse effect. So while a quarter of that CO2 has been absorbed by the ocean. By trapping part of anthropogenic emissions, the ocean mitigates climate change. But the dissolution of CO2, in addition to weakening the ocean's ability to absorb this gas by 30%, caused important change in the chemical properties of surface water. So much as the studies about the ocean acidification are growing, the synergic effects cause big concerns in ecology and economy. Research related to cultivation and natural change are often carried out, but however, studies on the synergy between the effects of pH reductions and salinity variations is still scarce. So why study salinity variations? Because of the impacts of rising water levels will result in desalinizations and flooding, particularly in deltas and coast areas, where they correspond to intense zones of the agricultural activity, including aquaculture. Even though they are extremely important, especially studies that report the effects on values stipulated by IPCC forecasts. So, see that the objective of this work was to assess the physiological effects with metabolism, nitrogen creation, types of the oxidative energetic substrate, growth and rate of food conversions, caused by the synergic effects of ocean acidification and salinity variations in the shrimp Lithopneus vannamei. So, the Lithopneus vannamei is the highest production marine shrimp in the world and may product from the several farms. Besides being one of the 20 most cultivated organisms in the world. And Primar is the farm project partner. It is an organic production farm which currently produces shrimp and oysters, and through the project began to introduce experiments of the multi-trophic culture systems, IMTA. So the animals were collected in shrimp farms, then transported to sustainable aquaculture lab of CAUNEST, and the animals were acclimated to lab conditions in aquariums containing water with salinity, pH, and temperature equal to that of collected size for 4 days. And after acclimatizations at experimental conditions, the animals were weighed and transferred to aquariums with salinity of 20, 25, 30, 35, and 40, and a group was exposed to normocapnia, pH 8, and while other group was exposed to the hypercapnia pH 7.3 for 30 days. So during this period, the animals were feeding with diet correspond to 5% of the initial biomass, and the diet contained 35% the crude protein. So the rest as food and feces were collected daily. So in the last day of experiments, the consumption oxygen, ammonia excretion, and atomic rations were measured, and the animals were weighted and measured. So the oxygen consumption was measured in a closed respiratory chambers equipped with an oximeter, and ammonia excretion was collected for the colorimetric analysis. And the growth ratio was calculated by difference between the initial mass and the final mass. So some of our results in this moment are the oxygen consumption increased about 52, 38, and 39% in the animals exposed to acidified pH in the salinity 20, 35, and 40 respectively, and probably due to an increase of demand, the energetic demand. So about ammonia excretion, the animals kept in saline 35 and pH 7.3, the ammonia excretion was lower 34%. And change, probably due to change in the exchangers or transporter. And in both pH, the animals oxidized protein or a mixture of the protein and lipids with the energetic substrate. So in relation to the growth ratio, did not present difference between the pHs, but in the salinities, the difference were in salinity 20 and 30 with the highest growth, with the animals' highest growth. And in relation to the hepatosomatic index, feed ration, and feces ration, the main difference occur in variations of the salinity. So the conclusion of these observations is that such changes usually are associated with impacts in the homeostasis, energy reserve, immunity, reproduction, behavior, and carry capacity of the systems. Therefore, government decision makers must be careful with the impacts caused by the reductions of pH in the ocean water and change in salinity from the increase of the CO level, because these changes cause effects in the biodiversity and in economic value organisms. So the next steps would be to understand and convey to all producers and our researchers that aquaculture production is entirely related to climate change, and that we cannot live about the evolutions of the sector without including the new climate conditions and mitigating measures for them. And we can see this in the diagram below, where you show the direct or indirect relationships of climate change and aquaculture. So I want to talk everyone and the Sustainable Aquaculture Lab, to my co-workers, and especially to 3 professors who always trusted and believe in your potential. The PhD Professor Wagner Valente, the PhD Professor Patrícia Cotrone Valente, and the PhD Professor Alessandro Augusto.
Thank you very much for this presentation, Andressa. We're now moving into the Q&A section of this meeting. So you can ask a question either by raising your hand or by writing in the chat. But while we're waiting for questions, Andressa, I would like to know, why did your study choose to focus on the white-legged shrimp of all animals?
Nowadays, the climate change is no longer just predictions. It is actuality already happened and changed many things we know about ecosystems. And so there is a need to study and understand this change mainly in the means of food production for the populations. And with that, some species stand out, as in the case of Lithopineus vanamei. So the white-leg shrimps, Lithopineus vanamei, is the most producer shrimp in the world, which raises interest in how these animals will respond to changed weather patterns. And so, as much as today there are many studies about the shrimp, the species, many do not take into the account the change that will occur in the physiological and chemical parameters of the water. So this can affect the productions in several ways, such as, for example, decrease in growth and consequently in the productions. And this context is the choice for the species.
Thank you very much. I don't see any questions so far in the chat or anybody raising their hand. So I will just make sure there's no other questions for anybody. And then I would like to ask another question. You mentioned that the partner Prima Organica have introduced the IMTA, Integrated Multi-Trophic Agriculture. Could you please elaborate a little bit about how this is done at Prima?
So Primar is a farm partner of the project. Primar is a farm that already produces shrimp and oyster today, and the project is testing a culture with organisms from different habitats such as shrimp, oysters, and algae. Shrimp is the Lithopineus vanamei, and with different densities of the shrimp with the oysters and algae. So it is a project that is still in progress, and experiments are being carried out to assess physiology, growth, animal survival, systems productions, in addition to economical, social, and environmental sustainability. And my contributions to the project is to understand how climate change, in particular ocean acidification and salinity variations, and will influence white-leg shrimp and consequently in the productions.
Thank you very much. Is there any questions for Andressa? You can just, yes, there's a question right here. Congratulations, Andressa. Could you please explain how the ratio O and N can help to understand the metabolism of the aquatic organisms?
So the ratio, the substrate oxidated and influencing metabolism. So in specific substrate, the animal need more or less energy for the process for the metabolism. So protein, and the animal need more energy for the growth in the process for catabolism, the nutrition and growth. Lipid is the more difficult for growth, but is less energy for the process. And change in the process can effects in the more energy for reproduction or more energy for growth and more energy for gain mass, and is the influence the direct in metabolism? You can understand? So.
It makes sense to me anyway. So I don't see any more questions. If nobody has any other questions, then here at the end, I would like to ask you, Andressa, what do you see yourself doing when you're done with your PhD? Like, what would be your dream job?
So I believe in this. My next steps achieve my dream job will be to continuing study the effects of climate change and also pollutions on ecosystems, on ecosystems and production systems, such as aquaculture. And in addition, to understand how the effects can be mitigated and how we can adapt to them. So I would also be to even know, about these effects and teach that to, sorry, é que eu tô mexendo aqui no computador. Sorry. So, should pay more attention to planet and nature. They teach the peoples need more attention to our planet and the nature and the ecosystems, and in turn of the human populations.
Well, that sounds promising. I want to thank you very much for giving your presentation today and taking the time to answer our questions, Andressa. I also want to thank everybody who has participated today. Please go to our webpage at AquaVitae project.eu. There's also a link in the chat. We are also on Instagram and on Facebook. My name is Kasper Tøring Juhl Dam. It's been a pleasure being your host today. So thank you very much to everyone.